All right, the goal of this recording is to talk through the Chapter 11 review. So let's get rolling. There's a few concepts that we need to know. A few of them, or the first few, are mean, median, and mode. Remember, the mean is the same thing as average. So I want to find the sum of all of those numbers and divide by the number of numbers. So in this case, I want to find what is 3.2 plus 3.5, etc. I'm not going to write all that out. When you grab a calculator and type all that in, I get 35.5. The number of numbers they tell me, or I could count, there are 9 of them. And so when I divide that, I get 3.94. What I do is I just double check. Does 3.94 look like it's about the average of those numbers? Yeah, looks pretty good. All right, median. I need to put these things in order from smallest to largest and find the middle. So smallest number looks like 3.2, and that happens twice. So as I cruise through, I'm just going to cross off the ones that I use. And then I got 3.4. And then I got 3.5s. And those all go away. And then I have a 3.8, I have a 4.2, and I have a 7.2. Okay? Median, middle number. If there are 9 songs, then the 5th number is my median. 3.5. Mode, most frequently occurring number. The number that occurs more than any other number. 3.5. There's 3 of them. There's 2 3.2s, but there are 3 3.5s. All right. Which measure of center, mean, median, and mode best represent the data? Remember, measures of center are my mean, median, and mode. If I have an outlier, the median is the best. Do I have an outlier? Is there a number that is very different than all the rest? Yeah, most of these numbers are between 3 and 4. That 7.2 is quite a bit bigger than the rest. So which one works the best? The median. Why? Because there's an outlier. So because there's an outlier, etc., etc. I'm not going to write all that out because it's hard to write on my screen. Okay? Median is the best explanation. Why? Because there is an outlier. Question C, what is that outlier? 7.2. How does the outlier affect the mean? Makes the mean, let me rewrite that. So the mean gets larger than it should. Gets larger due to the large outlier. Most songs are around 3 to 3.5 minutes, but this outlier makes that actually like 3.9. Look at all these songs around 3.2, 3.5, but the mean is actually almost 4. Well, there's only 2 numbers that are bigger than 4. So the mean really shouldn't be that high. But because of this 7.2, it makes it bigger. A better representation is at 3.5. How does it affect the median and the mode? It does not. Median, mode, no effect. That could have been 720 minutes, and it would still be a median of 3.5 and a mode of 3.5. An outlier only affects the mean. Okay, question 2. Table shows the heights of males and females for 14 people surveyed. We are going to make a double box and whisker. That simply means we're going to make 2 box and whiskers on the same number line. Okay, so we want to make a plot of their heights. Okay, so make a box and whisker plot of their heights. I don't care about their age, so that's just a column not there to distract you really, but it's just I don't need it. So now I'm going to put their heights in order from smallest to largest. Female first. So 3 is my smallest, and then 3.1. Again, I don't care if I'm mixing up the ages because I don't care about the ages. I just want to know their heights. 3.5, there's another 3.5. There's a 3.6. There's a 4 and a 4.3. Over here, smallest is 3.6, another 3.6, looks like a 4.1, 4.2, 4.3, another 4.3, and a 4.5. Okay, let's get our different pieces that I need. I need the min, I need Q1, I need Q2, I need Q3, and a max. We'll do females first. Whoops, I don't want that. We're going to do females first, and we'll do males next. Okay? All right, minimum female height, 3. Minimum male height, 3.6. Let's do the max. Max is a 4.3. Max is a 4.5. Median, my Q2 looks like 3.5 here and 4.2. My middle number, 3.5 and 4.2. Looking at the bottom half, my Q1 median is 3.1. My Q3 median is 4. This one's kind of weird. My minimum and my Q1 are the same. It's okay, kind of weird, but it's okay. My Q3 is 4.3. All right, we're going to put that onto my number line. So my minimum was 4.3, or no, sorry, 3.0. And I want to go all the way to 4. I'm going to count by 0.2s. So I'm going to go 3, 3.2, 3.4, 3.6, 3.8, 4, 4.2, 4.4, 4.6, 4.8. We're going to end here at 5. So minimum female is going to be 3, max 4.3. Looks like right here. This is 4.2. My Q1, I got all these stray marks. Let me get rid of these stray marks in here. My Q2 is 3.5. My Q1 is 3.1. Q3 is 4. Make my box from Q1 to Q3. Connect my max, making a whisker. Connect my min, making a whisker. And this is female. Okay? Male. Min is 3.6. Max is 4.5. Right there. I don't know why my pen keeps drawing little stray marks. Q2 is 4.2. Q3 is 4.3. Q1, again, that's the weird one. It's the same as my min. And so my box and whisker really is a box with only one whisker. And this is male. Identify the shape. Well, clearly the male is skewed right. The right whisker is way longer than the left because there is no left. And my female is also skewed right because the right whisker is longer. So they are both skewed right. Which gender has the longest spread? That would be female. Why? Because the range is greater. How do I know that? I calculated it. So the range for the female is going to be 4.3 minus 3.0, which is equal to 1.3. And the range for the male is 4.5 minus 3.6, which is 0.9. So the male or the female range is bigger, which means my data is more spread out. From max to min is bigger for the female. Which would the data set be better represented by mean, median, or mode? Remember, if my data is skewed on our homework, not our homework, but our notes packet, if the data is skewed, the median is better. Doesn't matter which way it's skewed. If it's skewed, the median is better. Why? Data is skewed. It happens that they're both skewed right, but it doesn't matter which way they're skewed. Okay, there's box and whiskers. Question 3. We're going to make a histogram, 30 people. We have an interval. First interval goes from 1 to 20, and so on. So I'm going to make a little frequency distribution chart. I'm going to do a range of numbers and frequency. Frequency. The first one was 1 to 20, so my next one is 21 to 40, and then 41 to 60, 61 to 80, 81 to 100, 101 to 120, and that's all I need. Okay? All right, looking at my information. From 1 to 20, I see 1, 2 of them. From 21 to 40, 21 to 40, I see 1, 2, 21 to 40, 3, 41 to 60, 41 to 60, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, I see 9 of them. 61 to 80, 1, 2, 3, whoops, 4, 5, 6, 7, 8, 9, 10 of them. 81 to 101, I see 1, 2. Oh, 81, 3, 4, sorry. 101 to 120, I see 1, 2. All right. Make sure the number of numbers adds up. We should have 30. 5, 14, 24, 28, 30. Yep, the frequency numbers adds up to 30. Looks pretty good. All right, next thing. I want to count. I'm going to count by tens. I missed, that's okay. We'll go out here to 120. All right, from 1 to 20, I'm going to count by ones up here also. Tens is as high as I need to get. We're good. 1 to 20 has 2. 21 to 40 has 3. 41 to 60 has 9. 61 to 80 has 10. 80 to 100 has 4. And the last one has 2. And we're done. Key. I think the key is to make this guy here. You don't have to. There's nothing in the problem that says you have to do that. But man, does it help organize my data. Highly encourage you to do that first. Okay. Next thing, two-way tables. We're asked to conduct a survey, etc., etc. As we read through this, we have to figure out our 2 categories. Okay, 230 students in your class. Ask whether they're attending a class field trip. 115 males respond. 75 are going to attend. 27 females are not going to attend. So I'm going to make my table. I have totals, so I actually have this whole thing. Sorry, I should have done that to start with. These are my joint inside, that first little box I drew, and then the marginals are on the outside. So what's my 2 categories? Well, I see a gender, and I see a class trip. So I'm going to say yes on the top, they're going, and no, they're not going. And I'm going to say male, and I'll say female. So we have gender and whether they're attending the class trip or not. 230 students were surveyed, so that goes in the bottom right-hand corner. 115 males respond, that's a total, that's a marginal frequency. 75 are going, and 40 then are not because there's a total of 115. 27 females are not going. Well, if there's 230 surveyed and 115 are male, then there also is 115 female. 115 minus 27 gives me 88 that are going. Okay? 27 plus 40 is 67. Hang on. 27 females are not going, which means 88 are going. And here we have what? 163. What just happened? Whew. Thought I lost everything. All right. Not sure why my computer is bouncing around. Sorry about that. Bouncing all over the place. Not sure what these stray marks are either. All right. There's some information. Question B. What percent of females are not attending? Not attending. So there are 27 females not attending. 27 out of what? Females. So there's 27 out of 115 females not attending. Notice I did not do it out of the total. Why? Because they told me how many or what percent of females were not attending. That was a 4, not a 5. Okay? So be careful when you read this. What are we talking about? Of females is the key. Read the next sentence. What percent of students? So now I know the bottom is 230 because now we're talking about all students. Question B. What percent of females? Now I know we're only talking about females, which there was 115 of them. Okay. How many people are attending? Well, that'd be all the yeses. So 163 out of 230, which gives me 71%. Be careful as you read the question. Okay, last one. Question 5. Identify the outlier. Well, it looks like most of these are around 1,500, 1,600, 1,700, and there's this weird one down there at 200. Outlier, 200. Does the outlier affect the mean? Yes. Mean will be lower due to the outlier. Okay, that's an N, not an M. The mean will be lower due to the outlier. Median, mode, no effect. 200 does nothing to the median or the mode. What is the deal with this 200 kilogram elephant? Why is it so small? It's a baby. Okay? Didn't say what kind of elephant. These are the masses of 8 elephants. 9 of them, or 7 of them are full grown, and 200, or the 200 kilogram baby, or sorry, can't talk. One of the elephants is a 200 kilogram baby. All right, hope that helps. See if I can find the recorder to turn this thing off. There we go. All right, see you.